Okay, so thus using the Kirchhoff's voltage law, we got this particular relation between the EMF and the current actually. Now the important thing is, because of the alternating EMF, some current is flowing. We can see that the current here, because the EMF is an alternating EMF, the current also will be an alternating current. So now the aim of the derivation is to get an expression for the alternating current itself. That means the current due to the alternating EMF, we are trying to get an expression. So for that, this is the main step. So immediately from this itself, we can easily get the equation for the current and prove that this current is really an alternating current because the EMF is an alternating EMF. That's the equation. That's the importance of the equation. Now from this, the very next step, actually there is no place here in this page, so I'll take a new page as a continuation of this. The next step is very simple. So taking minus IR to the other side, we'll be getting the EMF E, or the alternating EMF E is equal to I into R. That's the equation which we will be getting next. So that I'm writing in the next new page. So this is the empty page I have taken. So from this, the next step, so that implies, so just check the step once again. So this here, minus IR to this side, E is equal to IR it will be. So that's what is required. That's what will be the next step. So minus IR to other side, EMF E is equal to IR. But what is EMF E? Already we have seen that this is alternating EMF given by E naught sine omega t. So substituting that here, so E naught sine omega t is equal to IR. That's what we are getting. So here the alternating EMF E is equal to IR we are getting. So now aim is to get an expression for the current and prove that this is really, because the EMF is an alternating EMF, we have to, we already know that the current is alternating current. From Ohm's law we knew this. Even from the Kirchhoff's voltage law also will be getting the same thing just here. So taking R to the other side, we'll be getting the equation for current. But before that, substituting EMF E as E naught sin omega t from the first equation, that is equal to IR. Now the important thing is, what is IR here? The IR here is nothing but, just see here the diagram. IR is nothing but what? The potential difference across the resistance or resistor which is connected across the alternating EMF terminals. So IR is the potential difference from Ohm's law. V is equal to IR. We already know that, Ohm's law. So based on that, IR can be written as equal to the, so this diagram is important here. So actually this diagram is very useful for the sake of understanding. So I'll just do one thing. I'll just copy this diagram in the present page as a rough column. I'll just copy this. I'll just put a rough column here. If the diagram again here need not be taken, I'm just calling this clearly as a rough column. So in this, I'll just paste that diagram here in the rough column. So that's the thing. So the previous page, actually we already completed this, so this is not required. The previous page which we already completed, that itself I have copied here. So we'll not turn the page again and again. That we need not go to that board, whiteboard or blackboard. So instead of blackboard, here we are using a whiteboard, which is actually the screen of the computer. So we not go to that previous page again and again, or previous board again and again. So IR here is nothing but really the potential difference across the resistor, which is actually connected across the alternating voltage source. So that potential difference from Ohm's law is nothing but denoted as V from Ohm's law. So this is very simple, very important, potential difference across the resistor. So thus we are getting, so this is another very important step. Now from this, there is not a special result. What we are getting is E naught sin omega t is the EMF, or the potential difference across the terminals of the source, and that's equal to the potential difference across the external resistance. That's what we are getting. So from this we can just say that the EMF, the alternating EMF which is E naught sine omega t, which is nothing but both of them are nothing but equal to the potential difference across the resistor. So the alternating EMF is nothing but potential difference across the resistor. So this is very simple, not difficult to understand. The reason is directly it's a consequence of the Kirchhoff voltage law. In just one step, this can be remembered. Very simple. The algebraic sum of all the potential differences in a closed circuit is what? Zero. That's the simplest form of the Kirchhoff's voltage law. The algebraic sum of all the changes in potentials in a complete traversal of a closed circuit. That means the algebraic sum of all the potential differences in a closed circuit is zero. How many potential differences are there? Non-zero potential difference? Only two. One is the EMFE, one is the external resistance. So their sum is zero means one should be, the sum of these two is zero means one should be equal and opposite to the other. So equal and opposite. So neglecting the opposite nature, equal in magnitude. Both the potential differences must be same. Then only their algebraic sum will be equal to zero. So that way we can say that potential difference across the resistor is nothing but same as the potential difference across the terminals of the cell, which is nothing but EMF. So that way we can just take it to be this one. That's the meaning of this. EMF is nothing but potential difference only. That's what we are getting. So from this we are getting another very simple result. The potential difference across the resistor V, which is nothing but IR, is simply nothing but what? E naught sine omega t. So whatever things we are seeing here are simple. Nowhere any complication is there. E naught sine omega t. So thus we can see that the potential difference across the resistor is also coming to be a sinusoidal function of time. And this expression is same as the EMF of the cell itself, which is also the sinusoidal function of time. Now just see here. Now the maximum value, now here this step we have seen many times in the alternating current generator. The maximum value of sin omega t is what? 1. When this reaches maximum. So when sin omega t actually ranges between, if you take only the positive values, ranges between 0 and 1. Maximum being 1, minimum being 0. This way when it varies between 0 and 1, that is minimum and maximum, potential difference also will be varying between minimum and max, because potential difference is proportional to sin omega t. So when sin omega t is maximum, that is 1, then potential difference across the resistor also will be maximum. How much is that maximum potential difference? E naught into 1, that's nothing but E naught. So E naught already we have seen that it is a peak EMF or the maximum value of the EMF. It is also nothing but the maximum value of the potential difference across the resistor. So that is very important. So E naught is also nothing but called as maximum value of the potential difference across the resistor or voltage across the resistor. It's called as peak voltage. So this peak voltage is denoted by symbol. So E naught is also nothing but what? The peak voltage. So here this is very important. This is also not just the peak EMF, it's also the peak voltage or potential drop across the external resistance. So this also denoted specially by its symbol V naught. So then what happens to this equation? So V now can be written as what? V naught sine omega t. So this equation, so whatever things we are seeing here are simple. Nowhere any complication is there. This equation is almost similar to the equation for the alternating EMF. E is equal to E naught sine. Same thing actually. E is nothing but voltage. E is nothing but IR, voltage across the external resistance. V naught is nothing but the peak voltage. It's also nothing but equal to the peak EMF. So the same equation 1 is written as like this. So this is the next equation. Very important equation. So whatever things we are seeing here are simple. Nowhere any complication is there. Now equally important is, so this E naught sine omega t is what really? EMF E itself. So this equation also is a very powerful equation. We are getting this is the first step where we can see that the potential difference across the resistor R is a sinusoidal function of time. So this is the third result of the derivation. And this is almost same as this. This is almost same as this. So this is denoted as 3 dash. It's not a separate equation, almost same as 3. So I'm just calling it as, it can be just simply, that's why it's not given a separate name. V is equal to V naught sine omega t. So all these equations are very important equations. So we have to keep boxes for them. So I'm not putting boxes because the running notes is, I said I'll give the, always remember, so only a diagram you can take at the same time during explanation, because a diagram has to be drawn slowly. So I'm drawing it slowly, so you have to take down it at the same time. But derivation are just simple steps. Only listening is important, understanding is important. Anyhow, the steps will be simple, just based on very simple laws. Only understanding is important. So nothing should be written during listening while during the explanation. Later, once the explanation is complete, I'll give some time for writing the running notes, and I'll give short method for writing the running notes, easy manner. then only you should take the running nodes. Till then nothing should be taken down. So this is the next equation. So I'm not drawing boxes also during running notes itself while explaining how to write the running notes. Within 5 minutes at the end of the class, the running notes can be completed easily because it will not be much different. Only one or two lines somewhere here one line, here one, two or three lines before this particular step. That's sufficient. That will give the full running notes. That will complete the full complete running notes for the board exam. For the board exam only, the running notes, that is paragraphs explanation is required. But for the for preparation like entrance examination or for solving different kinds of problems for different kinds of examinations, problem based examinations apart from the board exam only theory is important. Problems will be few, will be there because theory is what is most important. So entrance examinations theory can't be asked. The reason is theory by hearting also it can be answered without understanding. So only problems, numerical problems are asked because numerical problems just one number is changed means answer will be changing. So it can't be by, it's not possible to by heart it. So though it doesn't really test the understanding is tested only by the understanding of the theory only. Problems are directly copycats of the scientific theory, scientific derivations. I said many times this so many times because problems are nothing compared to a scientific derivation. But that can't be asked in the entrance examination. The reason is a scientific derivation is standard. It can be by heart and written even by 6th class student also without understanding. That's why it can't be asked in the examination. So to ask questions on scientific derivation, it's very difficult to set the question. So nobody will be taking that risk. No time will be there for any teacher of any kind of university. So simplest way of conducting entrance examination is just by asking numerical problems because just by changing one single number, one single digit, answer will be entirely changing. So nobody can guess the answer. Without solving the problem, answer can be guessed. So that is to some extent uniform justice will be there for answers of all the students. So v is so okay. Coming back to the equation, v is equal to v naught sine omega. This is the other equation. So this is the equation for the alternating voltage. So v naught is the peak voltage. So it's same as E naught and v is same as E. That's the equation here. Now, very important thing is, so whatever things we are seeing here are simple. Nowhere any complication is there. Now just observe the equation here. So here just observe the previous step also here. Now from this equation, the equation for from this particular equation we have already seen that it is possible to derive an expression for current. So the same equation 2 we got it in this form. So just in this form we got. So then that is almost written slightly different manner, substituting equation actual expression for E in this form. Equation 2 has become this, and this in another way the same equation 3 is written as the equation 3 dash. So now from this, now substituting IR here, so whatever things we are seeing here are simple, nowhere any complication is there. Now again substituting V is equal to IR, this can be written as, so substituting 3 in 3 dash here, 3 in 3 dash. So V is nothing but what? IR, I into R. So it is equal to V naught sine omega t. Now from this current I is equal to V naught by R sine omega t. So in this again it can be seen that first time we are getting that current is also coming to be a sinusoidal function of time. So EMF also we already got as a sinusoidal function of time. That's why EMF is called as alternating EMF. So when sin omega t is positive, EMF E was positive. So equation 1, I'm not taking back, I'm not showing that equation 1 again here. So it's the same thing. So it was like this, E is equal to E naught sin omega t. When sin omega t was positive, EMF E was positive. Sin omega t is negative, EMF E is negative. Negative means in the opposite direction. That's actually positive means this one, clockwise direction. Negative means anti-clockwise direction. So that's the meaning. That's how the meaning should be taken for this particular equation. So when sin omega t is maximum, potential EMF E is, or the alternating EMF or alternating voltage is maximum. It's nothing but E naught, already we have seen. When sin omega t is minimum, that is 0, taking only positive values, E naught into 0 is 0. So the voltage, alternating voltage or alternating EMF will be coming as 0. The same way sin theta or sin omega t sometimes will be positive, sometimes will be negative. When it's positive, alternate voltage will be positive. So the same way here, when sin omega t is positive, current also will be positive. When sin omega t is negative, the EMF or the voltage across the resistor will be negative. That automatically even the current also will be negative. So current and voltage are negative means they are in the opposite direction. So positive means clock positive if it's taken as clockwise. If clockwise current is taken as positive, anti-clockwise current will be negative. The same thing is actually same result is actually obtained even from this also, from these equations also. That is equation say 3 dash and this next equation. This can be called as equation 4, but before writing the giving it the name equation 4, observe one small thing here. When sin omega take only positive values again now, when sin omega t is maximum, that is 1, current is maximum. That's called as the peak current. How much is that maximum current? Put sin omega t 1 here. V naught by R into 1 is V naught by R. So this V naught by R is the peak current. So this peak current is denoted as I naught. So the equation is written as I naught sin omega t. So therefore current is coming as like this. So this is the very important fourth step. The same thing is written like this. So where I naught is the peak current. So given by how much? V naught by R. It's equal to V naught by R. But what is V naught? A peak voltage. It's also nothing but same as the peak EMF of the AC source. So this can also be written as E naught by R. Now just observe here. This is very important equation. The peak current I naught, which is nothing but peak current, is given by peak voltage across the resistor or the peak EMF of the source divided by resistor or resistance of the resistor. Now this equation is similar to the Ohm's law equation. So Ohm's law basically is remembered from magic triangle, just like this way. So V I R. So V is equal to potential difference. Observe the cursor compulsorily. Potential difference V is equal to current into resistance, or current is equal to V divided by R. Now for a closed circuit, we have seen that in place of potential difference, EMF can be taken. In place of resistance, total resistance R total is taken. So Ohm's law is simply given by EMF divided by total resistance of the circuit. Now just see here, it looks exactly same like that. The current is equal to EMF divided by resistance, the same thing. Here we have peak current is equal to peak EMF divided by resistance, or peak voltage divided by resistance. So same Ohm's law form, we have the relation between the peak current, peak voltage and resistance. So it can be easily said that the peak current, peak voltage, we already know that Ohm's law is obeyed by current, voltage and resistance. The same way peak current, peak voltage and resistance are also obeying the Ohm's law. This is a very important thing. Its importance doesn't appear to be much here, but later in other complicated components, I said resistor is a very simple component previously also, where we can get this result, that is the equation 4 and 3. The current sinusoidal function of time, EMF sinusoidal function of time, directly using Ohm's law also we can get the results. But in other circuits, more complicated circuits, Ohm's law will not be helpful, especially in circuits containing components like capacitor and inductor. Ohm's law will not be helpful. There the Kirchhoff's voltage law only will be helpful. There also, in such circuits also, their components will be obeying the peak values like peak voltage, peak potential difference, peak current. They'll be again obeying the Ohm's law exactly like this. Though it's not a real Ohm's law, the form will be exactly like Ohm's law. That's why this particular representation is very useful. So therefore it can be said that, so whatever things we are seeing here are very simple, nowhere any complication is there. So hence it can be said that the peak current I naught, peak voltage V naught and resistance R obey Ohm's law. That is this particular magic triangle. But the meaning is what? So instead of the regular magic triangle is VIR. So in place of I we have what? I naught. In place of V or E, we have V naught or peak voltage or peak EMF E naught. So they also obey Ohm's law. This is another very important result. So whatever things we are seeing here are simple, nowhere any complication is there. Now again consider these two equations. Now just see here, the voltage across the external resistance, it's also nothing but at any time t. It's also nothing but voltage, already we have seen that it's nothing but EMF of the source. So the voltage across the external resistance, just look at the diagram, this is much more easier to understand. So this is a rough diagram. Actually this diagram was fair diagram in belonging to the previous first half of the derivation. So we are into the second half of the derivation, last part of the derivation. Diagram is not required again, but for the sake of understanding, the diagram will be much more simpler to use in understanding the equations. So I have redrawn the diagram here again. So only in the rough column I have drawn it. So because second time it need not be drawn. So now just observe here, the voltage across the resistor is coming as a sinusoidal function of time, and the current through the resistor is also coming as a sinusoidal function of time. Now just observe these two equations. This is also similar to E is equal to E naught sin omega t. Same, actually not similar, it's same as E is equal to E naught sin omega t. But the meanings are different. V is the potential difference or voltage across the external resistance. E is the EMF applied by the source, AC source, alternating current source. Really both the voltage and EMF are one and the same, because that we already seen because of Kirchhoff's voltage law. Both the algebraic sum of both these potential differences should be 0. That's possible only when these two are equal and opposite. That means equal in magnitude definitely. That way in place of V we can write E, in place of V naught we can put E naught. They're one and the same. But now the important thing is, when sin omega t is maximum 1, the voltage is also maximum. Even the current is also maximum. At some other time, sin omega t becomes minimum 0. Sin omega t is becoming minimum means voltage becomes 0 across the resistor, even current also will become 0. That means when voltage is reaching peak value, maximum, current also is reaching the peak value at the same time. That means it is also peaking at the said to be peaking at the same time. V and I peak at the same time. Peak means they reach the peak values, and same time, and also V and I become minimum also at the same time. So whenever potential difference across the resistor is maximum, current also is the same, maximum. When it is minimum, current also is the minimum, 0. When V is 0, I is also 0. Directly it can be seen because of their similar dependence. They are depending the same way on sin omega t, proportional to sin omega t. This is a very important result.